I want to find a fourth degree Taylor polynomial of this function f of x equals sine x centered at pi over 6, and then use Taylor's inequality, also called the remainder theorem, to estimate the accuracy of approximating the function with this polynomial on the interval from 0 to pi over 3. So the first thing I'm going to want to do is find the function at pi over 6. And so we know the sine of pi 6 is 1/2. Now I'm going to need some derivatives, and so I can take the derivative of sine, and we know that one's cosine, and evaluate that at pi over 6, and that one is square root 3 over 2. Now we're going to need some more derivatives. We'll take the second derivative, and the derivative of cosine is negative sine, and so if we evaluate that at pi 6, we would have negative 1/2. And now we're going to take the third derivative, which is going to be negative cosine x, and we evaluate that at pi 6, and that's going to be negative square root 3 over 2. Now the last one we need is the fourth derivative, and we've already now cycled back to sine x, and so we know that one at pi over 6 is 1/2. So we're getting all the pieces that we need. We have 1/2, and then square root 3 over 2, then negative 1/2, then negative square root 3 over 2, and then back to 1/2. So we can write this Taylor polynomial of degree 4, and that's going to be 1/2, and then we have plus square root 3 over 2, and that's going to have x minus pi over 6 because we're centered at pi over 6. Okay, and then we have the next one is negative 1/2, but that's going to become a negative 1/4 because remember that's divided by 2 factorial. That's x minus pi over 6 squared. Now as we look to our third powered term, we have negative square root 3 over 2, but then that's divided by 3 factorial, so that becomes negative square root 3 over 12, and that's multiplied by x minus pi over 6 to the third. And then our fourth powered term, we have 1/2, but that is divided by 4 factorial, and 4 factorial is 4 times 3 times 2, so that's 24. So that term's going to be plus 148 times x minus pi over 6 to the fourth. So there's our Taylor polynomial of degree 4 to approximate sine x at pi over 6. Now the next thing we're interested in is figuring out an estimate for the accuracy of this approximation from the interval from 0 to pi over 3. So looking at Taylor's inequality, we have that the size of the remainder is going to be less than or equal to m times the absolute value of x minus pi over 6 to the fifth. This is over 5 factorial. So let's see what we could do to figure out a good approximate here. So this m is an upper bound for looking at the fifth derivative, and so that is going to be less than or equal to m. And then the other thing is we're looking from 0 to pi over 3. So subtracting pi over 6 everywhere, we have negative pi over 6 less than or equal to x minus pi over 6, and that is less than or equal to pi over 6. So we could actually express that as x minus pi over 6, absolute value, is less than or equal to pi over 6. So that's going to be helpful to us for approximating here. But now as we look at what we could use here, well, the fifth derivative, we had the fourth derivative was sine x, so the fifth derivative is going to be cosine x. And thinking about cosine, the maximum it would ever be would be a 1. So we could take this and we could put a 1 where the m was, and in setting up the inequality. So we're going to have that the size of the remainder is going to be less than or equal to, we're going to replace the m with a 1, and we're going to replace the absolute value of x minus pi over 6 with pi over 6, and that needs to be to the 5th power, and then we have that still divided by 5 factorial. Now we could put that in a calculator and we get approximately 0.000328. So what that tells us is if we used the 4th degree Taylor polynomial that we have listed here to approximate sine x at pi over 6, our error would be less than this number right here.